Howdy, my name is Ryan Zeal, and I am the CEO of the United States Space Force Quantum Team. For this capstone project, our sponsor tasked us with developing a prototype communication methodology for legacy space systems, utilizing quantum-resistant cryptographic solutions. With the rapid development of quantum computers, there presents a serious challenge to the security and integrity of many existing encryption algorithms. This is especially concerning for legacy space systems, which are reliant on older cryptographic methods. Many of these space systems do not have the computing power to run modern cryptography. To combat these future attacks, it is essential that quantum-resistant cryptographic solutions are implemented into these legacy systems. The objective of this project is to design and implement a secure communication prototype that would be able to run on the limited resources available of legacy space systems. The solution will also be able to generate detailed network security reports to monitor the encrypted traffic. These reports will be able to highlight any vulnerabilities, such as packet loss, latency, and data confidentiality. Looking at our project diagram, we designed this communication network to include a ground station, which emulates collecting and sending data, a central server, which facilitates communication between clients, a network of legacy nodes, which emulate the limited resources of legacy systems, and a mission control, which is the final destination of received information. We have encapsulated all of these subsystems in a Docker image to ensure that this model can be run on any compliant device. Utilizing a Docker image also encapsulates the network traffic to ensure that we are generating the correct network analysis files. This also allows us to control things such as RAM usage, CPU usage, um, to better emulate the legacy space system environment. All encryptions used in this solution are open source and have been NIST approved, meaning that they have gone through a rigorous amount of testing and verification to be classified as post-quantum and resistant to quantum attacks. The two algorithms used for this client, the two algorithms used for the client and server handshake are MLDSA and MLKEM. The handshake is an identity verification process that allows only accepted registered clients with the correct keys to establish connections to the network. The AES GCM algorithm is used for packet encryption and authentication, which transforms packets of information into their encrypted state. This ensures that the data being transferred cannot be seen by unauthorized clients. The final algorithm used in the solution is SEAL. This is a homomorphic encryption, which allows users to do computations such as simple math on encrypted data without the need for decrypting it first. This is especially useful for legacy nodes as they do not require the computing power required to decrypt PQC algorithms. Instead, they can be sent information, say, from the ground station, do some simple needed calculations, and send it back to the mission control for further decryption. For the future work of this project, it could be scaled to include a multi-node communication network with different forms of communication. Currently, we are using TCP ports over a predefined network. This could be changed to include radio signals or other sorts of information transfer to better emulate different systems for the United States Space Force. Um, we also could work on integrating the network into various forms of hardware. Like we said, right now we're using Raspberry Pi, but other hardware might also do a better job. And also, this network is really easy to plug in different types of encryption algorithms. So in the future, if a better, lighter weight, or more efficient algorithm is developed and NIST approved, they could plug it into the solution and benchmark it against the pre-existing ones that we have. Finally, to touch on ethics, this project is conducted ethically by only using open source tools and data sets. We made sure to prioritize security and encryption. This was done, like I said, through the handshake processes and the PQC encryptions. And we applied responsible application of cybersecurity techniques. Moving on to our demo. We can show the starting of the server. We see that a Docker container is established and created, and the server listens on a predefined IP and port. And then if we go here and start the receiver, we can see that the connection is established and authorized by the server. It's sending packets of information saying, hey, this is who I am, trust me. And then it waits for the sender to connect. And once we connect the sender, we can see that we go through the entire handshake process, sending keys and authorizing them. And once this entire authentication and handshake is done, the receiver is ready to receive data. So if we go here, we can send it a packet. For demonstration purposes, we have shown the encrypted data. So this is what has been transformed from the sent packet of information. And the final thing to note for this demonstration is that after this has all been ran and the Docker containers are closed, there becomes a suite of captures for PCAP data, which essentially is a file you can plug into a program such as Wireshark, and it gives you an analysis of every packet that was sent over the network. With this, like I said previously, we can do a lot of different statistical analyses and compare our solutions to the required hardware necessary. Thank you.